at that time. And so he made the news, and we were like on the second page, and it was how could it be? There was some story about some gossip story. That's right, exactly.
Oh man,
Yeah.
timing.
And so yeah, the New York Times shows the inside of the beam tube with someone working inside of it during one of our.
That's in the detector.
That's in the detector at the sites. So,
Which one?
So this one, I actually don't know. I couldn't tell because they would be. This one is in Hanford, Washington.
Are they identical?
They are identical. Yes.
So when you're inside, you don't know where they are.
When you're inside, you couldn't tell where you are.
Yeah.
Exactly. Yes. There are subtle differences, but it's really hard to tell. And so this picture from here actually shows an aerial view of the Hanford, Washington detector. And so you can see this is a real picture. It kind of looks like a fake image, but this is, you have 2.5 miles going this way and then 2.5 miles going this way. This is what we call the corner station, where you have most of the detection happening. And so you have the laser beam that's coming out of a laser that's about 100 watts, and then it's split by the beam splitter that we'll see in a moment. And then the beam is split and then it's going down the vacuum arms 2.5 miles, and then it's reflected by the mirrors at the ends, and then it comes back. And then when it comes back, it goes out this way, and then at this location we have the actual photodiode that detects the change in intensity when the gravitational wave passes by.
Is it the change of intensity what the Earth is doing in relationship to the gravitational wave coming at it?
Yes. So what the Earth is doing is a noise source for our detector. And so one of the things we'll see is one of the main challenges of Ligo is to filter all of the noise source that are coming from the Earth. And so there is vibration because of earthquakes, because of microseism, from the waves crashing in the ocean. There are noise from cars driving by, trucks, and so all of those noises are being actively canceled out by seismic isolation systems.
So the computer knows that's the sound of a truck going, and then
that's right. Yeah.
So the seismic data is subtracted.
Some of it is subtracted, yes. Most of it is filtered entirely, and so the mirror are moving still because they're filtered entirely with a mechanical system that you'll see in a moment.
what was this area before?
This was, so the Hanford site is interesting because it's located close to where they made the plutonium for developing the bomb. And so it used to be a nuclear site. Yes.
Nuclear test site.
That's right. They were making the plutonium.
Oh, the plutonium came from here.
Yes, that's right. And so I think this area is owned by the state, and so they are lending us the land. So it's part of the. And so on the wall you have several pictures that you can see of what's happening inside the detector. So we can just go quickly.
That was your site where you were once based?
I worked at both sites, so this one and then the one in Louisiana.
Do you have tours there or no?
There are tours, yes. Yeah. The tours there are excellent, and they have science museums, and for kids it's wonderful.
Oh, wow.
Yeah. They have great exhibits there. On this picture, you can see that scientists being baffled by something they didn't understand at the time. This picture is taken inside our laser room. So this is where the laser is generated.
So it's a white room. I mean, you have to wear.
You have to. That's right. You have to wear
Clean room.
Clean room. Yeah.
Oh yeah, that's it. Clean.
This is a picture of someone inspecting one of our mirrors at one of the end station. Every time we go in the chamber and we exit, we have to make sure that there is no particles that are on the mirror that could disturb the light. And so we do those inspections. And then you can see other other picture of someone garbed up. That's close to, this is the ITM, one of the input mills.
Is the laser itself visible or infra?
It's infrared.
Infra.
Yes, so you can't see it, and when it's on, then we have to wear laser goggles.
Yep.
Sort of in vacuum, right?
So when we are going inside, then we have to, it's under atmospheric pressure, and then once we're done with upgrades, then we pull the vacuum. That's right. Mhm. Okay, we can go this way. And Marie has joined me for the tour. Marie works as
Hi.
a laser physicist in the group. And she's the one on the picture over there. Yes.
Which one?
Of the inspecting the.
That one?
Yes.
Cool.
I will have with this one.
And then this picture are people also doing some repair. There was some magnet that was broken at the time, and so they were regluing it. I happened to be there at the time, so I shot the picture. I'm proud of this one.
Oh.
It's nice. Okay. Come on in. We'll go around here. So this is a seismic and suspension lab. And as I said earlier, based on your question, one of the challenges of Ligo is to filter out all of that seismic noise, right? And so the way we do this is by suspending masses. And so the more stages of suspension you have, the more you filter out seismic
Vibration.
activities,
Yeah.
vibration.
Yeah.
It's kind of like your suspensions on your car, they damp the vibration. And so it's like if you're stacking up multiple stages of suspension on top of it, of itself, and then the more you add, the more you filter out those vibrations. And so you can see we have multiple type of suspensions in the detector. And then on my left here, this is one of the suspension that we use. It's a triple suspension, so there are 3 stages of isolation. And this is a replica of the beam splitter. So this is the same size as the actual beam splitter that split the laser into the 2 arms. So the optic itself is the real size of the beam splitter. We just upgraded it, so now this is the old version of our beam splitter. We now have a new beam splitter that's larger, and so new suspension had to be designed for that. It has been designed by a group in Glasgow, and then they shipped us the part and we assembled it at the detectors, and then we just installed it a month ago, and now they're actually sending the first lights into that new suspension to see if it works. So it's very exciting time.
Have you noticed the difference?
So we're not that far yet in the process to figure out if it's better. It should be better. We're not there yet.
It's just slightly bigger. Just do it this way. The suspension, the optic is just slightly bigger. It's because it was hitting the beam before. It was a limiting aperture in our system. So now it's just above, so it should be better.
Because the beam is
That's the size.
the size of the beam is quite large at that point, and so
How thick is the beam?
how wide? I think it's about. I mean, it's probably about this much. It's like 40 centimeter diameter, 20
Wow.
centimeter radius, about that size.
The optic is
Radius. The optic is 40 centimeter.
And the power is at 100 watt.
Power is at 100.
100 watt.
Yes.
Okay. So that area is the whole area is 100 watt.
That's right. Yeah.
Got it.
Were you part of the design team to make it bigger?
I was part of the testing team. So when I started working on the detector, I was a suspension testing engineer, and so I would suspension was already installed, and I would do all the tests mostly from the control room to make sure that all of the actuation system and the sensing system was working as it should.
What kind of test? Like heat or cold or just bounce it?
Shake it.
So
You shake it from the
Oh,
top,
you're shaking.
and you see how much it moves.
So you put it in a machine to shake it.
So actually, there are on any of those systems, you have sensors and actuators that allow you to control the position of the test mass. So you can push on it in all degrees of freedom. Kind of like on a telescope, if you want to point at a given star. Here it's the same because you have to remember you have a beam that's going in one way, and then it has to hit the mirror that's on the other side at 2.5 miles away, and so you have to make sure that it's pointing in the exact position. And so for that we have actuators inside the system. And so that's one of the.
Actuator. It's a coil, so you can send the current through the coil. And on the suspension we have magnets, and with the coil we are pushing the magnets, and we make the suspension move as we want. So it's a very clever system. And it's, at the same time, it's a sensor because it's called a shadow sensor. Inside you have a light, and when the suspension moves, there is a little flag that cuts the light more or less, and then you can measure displacement. It's very clever.
Were you able to break it?
So not myself, but there was. So that was before my time, thankfully. But there was. So that suspension is one thing. It's hanging from active isolation platform. So on top of this, you have two stages of like an active robot that cancels out the vibration on top of that. So imagine that this platform currently that suspension is attached to. Imagine that's also another active platform to cancel out the vibration.
This is the third stage itself.
So that would be 2 stage. There's actually 3 stage on top of this, and then 3 more stage. So this one is 6.
It's 6. Gotcha.
Yeah, that's right. And so one time there was an excitation that was going, and we didn't know, and so it was shaking, and those very thin fibers that are holding the mass, they broke. And so since then we had to put a lot of security into the system. Those things happen. We can go this way because it's ready to.
Yeah, they do too.